So now let's go back to our ramp situation. I know last week we did ramps ignoring friction, but now let's think about what friction would actually do. And suppose this problem asks you to find the acceleration of a 16.7 kilogram object down an 18-degree incline where the coefficient of friction is 0.225. So believe it or not, just that little bit of information is enough to solve this problem. So I've started to get a diagram going, but really this is an incline, so I need the imaginary horizontal base of that to get my angle written. So my 18-degree angle will go here. I have an object that is 16.7 kilograms. And I know that it is basically sliding down this. And so I have a bunch of forces going on. We want to get those in here. So the force due to gravity always acts straight down. I also know that I have a normal force, which is going to be perpendicular to the surface. So if my surface is here, imagine taking a 90-degree angle to that, so basically there. So I have my normal force acting in that direction. I have my friction force opposing the motion of the object. So if the object is sliding down the ramp, friction is going up the ramp against the bottom of the surface, of the object. And then I also, let's see, am I missing any other ones? No. In this situation, a lot of times we've had a pull force, but this object is a free falling, and by free fall, I mean it's allowed to just freely go down the incline. So there's no other force on this, but we need to figure out how fast it's going down the incline. So now, the first step you should do is to find the gravity force. That's always the first thing you want to do. So Fg equals mass times acceleration due to gravity. And so my mass was 16.7 kilograms. Acceleration due to gravity is negative 9.81. Both have three significant figures. So we want to round our answer to three significant figures. So 163.827 will round to 164 newtons, and this should be negative. So after you find the force due to gravity, we want to find the normal force. But if you pay attention to what's going on in our diagram, all of these are not acting in the same direction. We have this direction along the incline, we have the normal force perpendicular to the surface, and gravity straight down. So we're going to have to break this stuff into components. Easiest way to do that is because my friction force and the normal force are perpendicular, let's actually rotate our x and y axis to be along those two. So let's draw a diagram over here where if this is our surface, this is a perpendicular, those are going to become our x and y axes. So the surface is our x-axis, this is our y-axis. So drawing our vectors on this diagram, normal force is perpendicular to the surface, so that's along our y-axis. Oops, I was thinking ahead. That's our normal force. Our gravity force is straight down. So from here, literally go straight down. And then our friction force is along the surface. And we made the surface the x-axis. So I want to put that on the x-axis, but it's moving up on the x-axis, which is actually in the negative direction. So now if you notice, both the friction force and normal force are on the axis. The gravity force is not. And if you remember, our incline angle, whatever that is, 18 degrees, that always goes between our gravity force and our y-axis. So the 18 degrees is going to go here. So we need to break up this gravity force into the x and y components. So there's a start of a right triangle here. Gravity force is always going to be our hypotenuse. Here's a side. Can we make a perpendicular angle? We need to drop a perpendicular, so that means there is our right angle. So now, the two sides of this side will be FG in the x direction, and this side will be FG in the y direction. So now, again, FGX, if you notice, is opposite. So we're going to use sine for that. And so that's going to be 164 sine of 18. Now 18 has two sig figs, so really our answer should have two significant figures. So this is going to be 51. And because this is moving in the positive x direction, we're going to leave that positive. Well, FGY, I know on the diagram it's yellow, but I'm going to keep writing in purple, is going down, so that's going to be negative. And since yellow is hard to read, I'm actually going to go over this. So I'm going to do 164 cosine 18, and that ends up being 155.97. Now we need two significant figures, so this ends up being 160. It's 2 because the angle is only 2. So now we're one step further. Paying attention to this, we are trying to find the acceleration of the object. So I always want to go back to what we're trying to figure out. We're trying to find the acceleration of the object down the incline. So we're looking for this acceleration. So in order to find that acceleration, we need to find the net force in that direction. Well, there are only a few things going on in that direction. In that direction, we have the friction force. So in other words, we want to know all the stuff in the x direction. We have the friction force, and we also have the gravity force in the x direction. So eventually, in order to get acceleration in that direction, we need to find F net along the incline. Well, in order to get F net along the incline, we know that F net is going to be friction plus gravity in the x direction. We already have gravity in the x direction, so we need to find friction. But in order to find the friction, we need to find normal force. So your next mission is to find normal force. And hopefully you accept this mission, and that normal force, we need to look at the y direction. In the y direction, normal force and gravity in the y are the only things. And because we have equilibrium in that direction, normal force plus gravity in the y must add up to 0. Well, we already have gravity due to the y, and really, I apologize, but because gravity in the y is going down, these should be negative. So we get the normal force equals 160. Now that we know normal force, it's very easy to find friction force. Friction force is the coefficient of friction times the normal force. Remember fun, F-U-N. And so this is going to be the coefficient of friction they told us was 0.225. Normal force 160. Multiply those two together, and we need two significant figures. And so actually it comes out perfectly to 36. But because this friction force is acting up the ramp or in the negative x direction, sorry, I don't know why my Pandora thing's popping up, that should be negative 36 newtons. So now that we have friction force, we can finally get back to where we want to be. And my net force in the x direction, I usually like to write net to be separate from normal. So if I write F capital N, that means normal force. I will always write F net for the net force. Friction force we just calculated was negative 36. Gravity force in the x direction, where do we have that, was 51. So if we add those two together, we get 15 newtons. So in order to get acceleration, we get to use our force equals mass times acceleration. And if I really want to be picky, I can label this acceleration in the x direction to be separate from acceleration due to gravity. And so mass 16.7, acceleration is what we're looking for, and 15 newtons goes here. Acceleration will have two significant figures, so 15 divided by 16.7, 0.898. With two significant figures, that will round to 0.90 meters per second squared. That is your final answer. So this is actually very similar to number 3 on page 141. You do have to find the coefficient of friction in part A first, so you kind of have to work backwards with that problem. If you're trying to find the coefficient of friction, your coefficient of friction is always in this equation, so you need your normal force and friction force. Once you find the normal force and friction force, it's very easy to find the coefficient of friction.